today we got medium problem A53 car fleet, so we are n cars at some positions from mile 0 and traveling to reach that, and they have speeds, and you are given two integer arrays, position and speed, blah blah blah. You cannot catch up to it. Car fleet is a single car of group of cars that are blah blah blah, minimum of anyone in the fleet. If okay, so some sort of a simulation. We got 10 to 5 of them and positions are unique. Okay, speed is 10 to 6, so here so 10 to 5 and target is 10 to 6, so can overflow. Well, what I would do is go from the last one and return number of car fleets. Okay. So I would sort the cars by position, right? So let's do this. And len position, C list range, N C sort key lambda X position X. Should work. Let's see. Should be like 2 4 3 1 0. That's weird. What? Oh, 2 4 3 1 0. Okay, so it works. So now that we got the cars, I actually want to go from like this, right? And then what to do with this? Good question. So we go backwards through the cars, and now, well, we know when this guy arrives, right? We care only about the fleets, not when they come, so that's good. So what I'm thinking is then, let's say we start with the last car, and then its speed will be whatever, right? And then I check this guy, right? Because he's at 8, his speed is 4. So technically, you know, he will arrive at the same time. So I put him into the fleet because his arrival is less than or equal to the current arrival, right? Then I pick 5. And now 5's arrival is at time 7, whatever. So, or it's time to know 7, right? So arrival target plus 1, I guess, or target plus y. And now 4 cars, 4 car in cars. So this is what I'm doing. So fleets. Now arrival of this car is equal to target minus, so target minus position of car, and then we need to divide by speed, speed of car. So we want to do plus speed of car minus 1 because that's a ceiling trick, right? So this is the arrival. If arrival is less than or equal to current arrival gonna equal to this, right? Then if it's less than or equal, sorry, to arrival, right? So if the car can come sooner or at the same time, then nothing changes, right? And it will arrive at that time. Otherwise we want to do current arrival is equal to arrival, right? Fleets plus equals 1 and return number of fleets. Wrong answer, 0. Damn. So let's do this. Okay, I was a little worried there that it's gonna work immediately. Okay, so I should just do like a straight up division like this. Okay, fair enough, I guess. Let's see. Okay, it's quite good. Didn't expect to do it so fast. Sorting plus math. Okay. Suppose we sort the cars by position and go through them in decreasing order. First car, let's say there is already a fleet which has an arrival time of current car is at position car and has a speed of speed car. How do we calculate if the car will become a part of the fleet or not? Compare the arrival time of the compare arrival to arrival time of the car, which is car divided by speed car. If the car arrives at the same time at the latest, it will become a part of the previous fleet. Otherwise, it will form its own fleet, which will never catch up to the previous fleet due to the minimum speed condition. This way we basically just simulate the fleets arriving. and log, and since we've of the cars, since we first sort them by their positions and then just iterate over all of them, doing O1 work for each of them. Space complexity 1, since we do not have, we only use ON, since we I mean theoretically in place, whatever, since we store the cars themselves and okay, post. Okay, goodbye.